We are working on the bit by bit project from the YByte Python curriculum available at www.ybyte.in. Having seen the three basic building blocks, the AND operator, the OR operator, and let's say the XOR operator operating on a single bit, now we are in a position to extend our argument and see how bitwise operators work. Well, as we discussed, so the big picture view here is that I'll be providing two integers and the output also will be an integer. But internally, the integers will be handled in a very special manner. In fact, both the integers that we are giving as input will be converted to binary. Now, in our case, we are limiting these values to be between 0 and 255, which means that both of these will be 8-bit numbers. Now, having done this, we will do, depending on what we are doing, AND or XOR, we will do, in this case, in case of AND, we will do bit by bit AND. So bit AND between these two bits, between these two bits, and so on, which means that at the end of this, we will again get a binary, let's say number with, let's say, same number of bits as the inputs. However, the function will return us not the binary representation. In fact, the function will again give us the equivalent decimal value. And that's why I've said integers in decimal. And again, output is also an integer in decimal. Now, this is best understood with an example. So the way, let's look at this. Let's say I was to do a bitwise AND between 43 and 157. The symbol is this ampersand. Now, the way it works is, like I said, 43 in binary is 00101011. Now, we can see this, we can in fact see this from here. If I did bin, say 43, that is, here it's like 101011. But remember, I want to, so that's basically 6 bits. But remember, I want to represent this as an 8-bit number. So that's why I put 00101011. And you notice that's what we have here, 00101011. Again, for 157. So if I were to do bin, let's say 157, that is 1001. So that's this 1001 1101. So if I were to look at that, 1001 1101. Now this part of the, let's say, conversion is happening implicitly in the function. We don't have to do it ourselves. The function is doing it for us. And what is the function doing? Well, it is then doing an AND of each of these bits bit by bit. So for example, I do 0 and 1, hence I get a 0. I do AND between 0 and 0, I get a 0, because remember, AND gate, any one of those values is 0, the output is 0. So in all of these, I get a 0. However, notice for this particular bit, it's 1 and 1, and that's why I end up with a 1. This is 1 and 0, again a 0, 1 and 0, again a 0, 1 and 1, I end up with a 1, which means that I'm ending up with a binary representation, which is 00001001. Now, the equivalent of this is 9, and that's because this is 1 plus 0 times 2 plus 0 times 4 plus 1 times 8. So that's actually 8 plus 1. This is 9. In fact, we can see this ourselves. If I were to do int, let's say 1001, say 2, 2 for binary, I will get a 9. In fact, if in case you're wondering, so what happens if I do this? Well, no change, because leading zeros on the left side do not change the value. So this is 9, which is why if I were to do, say, 43 ampersand 157, this is going to be a bitwise operator and it returns me a 9. Remember, the inputs are integers, the output is also an integer. So that's a bitwise AND, basically an AND done on every bit by bit. But the external interface is still decimal. That's why, we give numbers and we get out a number. I hope this has been clear to you. At YByte, we always build concepts in a step-by-step manner by giving examples and eventually using them in an activity so that they become really, really clear. Look at our website, www.ybyte.in, to find many, many, many such activities, because we learn Python programming through fun activities. Take care. Thank you so much. Bye-bye.